Hello. In this video, we are going to discuss about the modifications of Turing machine. So broadly, we have two variants of Turing machine. The very first is multiple track Turing machine. Another one is non-deterministic Turing machine. So when we are talking about the variants of Turing machine, we are generally focused on how powerful a machine is. Okay. So whenever we design a machine, we can compare two machines only by their power. As if you remember that deterministic push down automata has not the capability as the non-deterministic push down automata possess. But in case of Turing machine have the same power in case of any of its variant. So we are going to see this how it is going to work. So coming to the very first multiple track Turing machine. In multiple track Turing machine, we have multiple input tapes, or we can say multiple tracks. Okay. So just taking a simple example of a raised to the power n, b raised to the power n. If we have a single tape, then we are going to store the input string on this input tape. So I have taken here an example of triple A, triple B. Here we have blank. Here also we have blank. Now the head will start from here. This A will be converted to blank. Now the head will make a movement to the first B. Now this B is converted to blank. Now the head will again make a movement to this A. This A is now converted to blank. Now again a movement in this direction. This B is converted to blank. So when we are making these moves, what we are actually doing? We are on the first symbol. We are moving ahead by n symbols. Then again we are coming back by n symbols. Then we are moving n symbols. So likewise we are making n cross n movements. So a total of n square movement, and we can say there is a time complexity of on square. Okay? Whereas if we have multiple tracks, say if I have two tracks, then I can put my input string on both tracks. So here we have blank, here we have blank. So we have just copy pasted our input string on both tracks. Fine. Now we will make a move from here and here. So we will convert it into a blank and we can shift here. At the same time we have make this blank, we can convert this B to blank. Now we'll convert this A to blank, we will convert this B to blank, this A to blank, this B to blank. The process will stop here in this step when we reach the first B, and the process will stop here when we reach the first A. Okay, so we can easily make a comparison whether this number of A's and number of B's were equal or not. Now we have made n movements here, n movements here, and when we have reached this B, we will go back. So we will make another n movements here. So there is a total of 3n moments in case of multiple track machine. So overall the complexity is O(n), that is order of n, whereas in single track it was n square. So we have seen that by making a modification, we have improved the time complexity, but there is no change in the power of the machine. By power of the machine, we means that the machine is capable of accepting that particular language. So both machine are capable of accepting a raised to the power n, b raised to the power n. Okay. However, definitely there is a difference in time complexity. Okay. By having multiple tracks, we are getting the result faster, but that doesn't make an impact on the power. So both machines are equivalently powerful. Coming to the another variant, that is non-deterministic Turing machine. So a Turing machine takes a state, takes a tape symbol and makes a move to another state, changes a input step symbol, and make a move in a direction. This direction can be either a left or right. However, in case of non-deterministic, we have the power set for same. So we can have multiple movements corresponding to the set of state and the input symbol, or we can say the tape symbol. So the same pair having the state and this tape symbol can have the multiple moves defined. Fine. So following the same procedure as we followed in finite automata, we will make a replacement of this here. So we can achieve the non-deterministic Turing machine and the deterministic Turing machine. However, again, when we talk about the power of Turing machine, which is deterministic, and the non-deterministic Turing machine, their powers are same. Okay. So these were the two variants of the Turing machine. Thank you so much.